Okay, this is 6.6 Illustrative Mathematics. Save this file. The Brits baseball reaches a height of 103 feet in about 2.4 seconds, as seen by this graph, given the equation. And using the negative b over 2 times a, h of negative b over 2 times a to actually mark the maximum height. I see how far Brett threw the baseball up and how long it took. Looking at the assignment here, um, the height of Andre's baseball is there. He threw it. Say for the assignment 6.6. Now take a look at the graph. What we need to do here is mark this graph. This point at 1 second seems to be at not 50. Now I have to see when that intersects. 3.1 maybe, or 2, 3.3, 3.4, 3.5. 3.1 is at 60, and so is 1.1. And 0 could be 5. Geez, these are just approximations. So let's take a look. Let's make a table. Let's add it. So at 0, at 0, at 1.1, 3.31. So at 0, we're saying it's maybe 5 feet. And looking at the graph, 5, 10, 15, 20, maybe 5 or 6, 1.1 second, 1.2 seconds, 1, 1.2, 1.2, 4, 1/10, let's see, 1, 2, 3, 4, 5, so 60 each time. And if that's the case, then we can say y1 tilde ax1 squared plus bx1 plus c would give us a height. And 2.1 seconds only of 76 feet high. So we see 80. Let's take a look at that. It is under 80. So without all that detail, we could see it was under 80 on the graph. So from here, Andre's data can be modeled as below, with the equation below. And 2.176. Sustained gravity, so we can change that. Initial velocity of 67 of B, and the height of C. And I should change that to X. Yes. So there's the function. After regression. Let's see. Even if it's as tall as the other person, starting at the same place, it doesn't get much higher than 100. Can't get as high as Brett. So let's adjust that. Make the guy taller, or he can't be that short. Let's see where he gets the ball. At 5 feet there, 6 feet, maybe as tall as that. It doesn't change that much. Okay, so definitely the gravity is the same. How fast you initially throw it is B, and how from where you throw it, the height C. Its initial height. And there again is the height. Around 2 seconds. We can mark it with the formula, which would be B divided by -32. Comma F, in this case, F of we should say 100. B divided by 32. Depending on how tall Andre is. Even if it's 10 feet tall, he couldn't do it because he's not throwing it fast enough. So leaving him at even on the short side doesn't change much. So he, at most, he takes about his throw, Andre's throw, takes about 2 seconds to reach a maximum height of about 76 feet. To answer the question, who threw it higher? Brett threw it higher. Quote, Brett throw is higher. Takes about a half second longer. To go 100 minus 4 minus 76. Than Andre's, and it takes about half second longer to go. 4 plus 3 is 7. Excuse me. Okay, so Brett's throw is higher than Andre's and takes about half a second longer. Throw takes about half a second longer to go. One is 76 feet, 27 feet higher. Higher than Andre's. And here, Brett's equation. Andre's data can be modeled like this, based on this data. I got the equation. See? Okay, saving it. Okay, so we just saved this one as the baseball problem to answer all the questions. Who's right? That's right. Okay, so now let's go on to the financial.